All right, so here again we have natural gas price. So this is the average price per 1,000 cubic feet of natural gas for residential use, and it's modeled with this quartic function. So there's a lot more things here, terms. And this is the number of years since 2000, and we want to look between 2003 here and 2008. But then the inflection points we want to look for between 2004 and 2010. So what we'll do is we'll follow what they ask, and then we want to find the inflection points and the rate of change. So basically, we're going to have to find our first derivative and our second derivative of p. Okay, so we multiply that out. So we have 0.0987 times 4. So we get 0.3948 x third minus now 2.1729 times 3. So that's going to be a 6.5187x squared plus, now it's going to be somewhere 34.054 or something like that. Yep, 34.054, 34.054. And that's going to be x, and then minus 55.023. And that's going to be dollars per year. And so then the next one we take, and we'll take our 0.3948 times 3, and we get 1.1844x squared minus then 6.5187 times 2, 13.0374x plus 34.054. Okay, so that's going to be again dollars per year. Okay. And so now what we need to do is set this one equal to 0 and solve it. So let's see if we can do that using our calculator. So let's get rid of all this and let's plug in. We want numeric solver, and so we'll solve this one, and we want 1.1844 x squared minus 13.0374 x plus 34.054. And let's graph, let's plug in, and now what we wanted, it was between the 4 and 10, I think it was. So let's do a 2 and say graph. So 4.262 is going to be 1, and if we put it in the other side closer to 10, we get 6.745. All right, so let's do those. So we got x was equal to 4.264 and x equals 6.743. Again, we used our numeric solver on this here to solve for those two. So now what we're going to do is we need to do the inflection points and all that stuff. So the question is it going to be quicker to type this in and then have it do it all itself, or is it going to be quicker to type it all individually? I think it's going to be easier to type it in by itself, so we're just going to do that. So that was 0.0987x to the 4 minus 2. All right, and then we'll put the derivative here. And so that's an 8, and that's x. Oops, that's a y1, and that's an x. All right, and now we want to go, let's just do it between 2 and 8, and we'll do by 1, and we'll go from negative 20 to, I don't know, 250. or 525 even, that works too. And so now we'll kind of get those two graphs. They're way down there, so we really didn't need to go that high. And so if we trace, how high do we have to go? And we'll go to 40. All right, so that looks okay. And so what we're going to do is we want to calculate the values of both of those equations. So we want to at 4.264. All right, so that gives us 11.264 for the inflection point on the top piece, and it gives us 2.270 for our rate of change for the bottom one. Okay, so we got those. And now what we want to do is we want to do 6.743. And so here our rate of change was negative 7.7473. And here it was the point of inflection was at 13.152. So let's go back here now that we've got all of our data. And so P of 4.264, P of 6.743, and that's going to equal, that was 11.264, that was 13.152, and these were dollars. Okay. And then that was our inflection point. And so then we had P prime of 4.264 and P prime of 6.743. And that one that said was for 4, that was 2.270, and that was negative 0.747. Okay. So that was, this one was going to be dollars per year, and that's negative dollars per year. Okay. So now what it says is we have to, anything else to do to recalculate change, inflection, answers, okay. And so that is the answers to part A. That's probably supposed to interpret, I bet. Let me check the book. Number, natural gas price. Yeah, that's supposed to say interpret. All right. All right. So what we have then is between 2004 and 2010, the average price per 1,000 cubic feet of gas, natural gas, was, now it was, I guess we can say, increasing most rapidly. And we probably should write down when these things were. This was going to be 2000 plus 4, 2005, and this is 0.246. So that's going to be, so it's going to be, looks like April 2005. And this one is going to be in September of 2007. All right, so the between 2004 and 2010, the average natural gas price per 1,000 cubic feet of natural gas for residential use can be found as that was $11.26 for that 1,000 cubic feet in April 2005, and it was increasing by $2.27 per year, and it was decreasing most rapidly in September of 2007. Its price was $13.15, and it was decreasing by 0.75 or $747 per year. It was decreasing by, so the negative. Okay, and so you'd have to write all of that out, and so you'd kind of have to interpret what each of those meant, and then write those out. Okay. And I'm not going to write all that out because that'll take us forever and you won't be able to read my writing anyway. All right, so let's pause there and we'll come